using the derivative and the alternate derivative formulas. Suppose we wanted to find the derivative of good old f of x equal to x squared. Well, we know the answer. I stated it twice so far. It's 2x, but let's do this. F prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. And it's all algebra with two exceptions. I'm going to keep writing limit a lot. And in the end, I'm going to replace 0 for delta x. Now, just for the record, if I replace 0 for delta x right now, if I replace delta x with 0, x plus 0 is x, so I get f of x minus f of x over 0. I get 0 over 0. That's indeterminate. Somehow I want to cross off as 0 over 0. In fact, we want to cross off every time delta x over delta x. You want to cancel out delta x over delta x each and every time. Now, I'm a firm believer that you need to be able to say what the function does in words. No matter what you put in there, what does f do to it? It squares it. I couldn't care less what you put in there. You can put happy birthday in there. I couldn't care. I'm going to square it. Minus whatever you put in there, I'm going to square. Or you can say, oh, you were given that f of x is x squared all over delta x. Remember, if you have a squared minus b squared, a and b are being squared. You can add those two things and you could subtract those two things. Here, x plus delta x is the a, and here, x. So, I'm still doing algebra. I still write delta x goes to 0. I add these two things. I get 2x plus delta x. Then I subtract them. X plus delta x, take away the x, that just leaves me with delta x. All over delta x. Look at that. As promised, the delta x's will cancel. So what you have is, the limit is delta x goes to 0 of 2x plus delta x. So far, other than writing down delta x, the limit, all I did was 100% algebra. The calculus was just writing down limit and knowing the formula. Now, the hardest calculus, the hardest part of the calculus, wherever you see delta x, plug in 0. So you get 2x. Just calculus, 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 calculus. Plugging in 0 for the delta x. Everything else was algebra. The calculus was literally trivial. You may not know why you're writing this, but you keep writing this, you keep writing this, you keep writing this, and when after you cancel out delta x over delta x, plug in 0 for delta x, and you're done. Notice, once I plugged in 0 for delta x, I do not say limit anymore. I do not say limit anymore. Only say limit when you're honestly taking a limit. And when you're evaluating 2x plus 0, you're no longer taking a limit. Suppose you come to learn that f of x is equal to 2x squared minus 3x plus 5. So what is the derivative? Well, it's the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And we're going to keep writing limit a few times as delta x goes to 0. But everything's going to be algebra. What does f do to what's inside? It squares it and multiplies it by 2. Then it takes away 3 times it, and then it adds 5. Okay, I'm going to square what's in there, and then multiply it by 2, and then take away 3 times what's in the brackets, and then I'm going to add 5. Minus, again, you have 2 options here. You can do what's in there, or you can say, hey, I know what f of x is. They told me. It's 2x squared minus 3x plus 5. I guarantee you, everything in here is going to cancel out with stuff in here. So, it's just all algebra. What is that squared? It's x squared plus 2x times delta x plus delta x squared. It is not delta x squared. It's not delta x squared. It's delta x all squared. Okay, minus 3x minus 3 delta x, and then plus 5. And I'm supposed to take away 2x. Okay, minus 2x squared minus 3x plus 5. Oops, all over delta x. All over delta x. It's all algebra so far. Other than writing down this stupid limit as delta x goes to 0. Do not take calculus if you don't know your algebra. This is 2x squared plus 2 times 2 is 4x delta x plus 2 times delta x squared minus 3x minus 3 delta x plus 5. Okay, this is all distributed out in the first bracket. So I'm supposed to take away 2x squared. Okay, I'm supposed to take away minus 3x. There's minus 3x. I'm to take it away. It says take away. I'm supposed to take away positive 5. I did. And all of this is over delta x. I guarantee you that what's left over in the numerator, every term that survived in the numerator has a delta x term. So let's factor it out, delta x factor. So here we have 4x plus 2 times one of the delta x's that we didn't factor out, minus 3, all over good old delta x. And this cancels. Again, other than writing down the formula, all I've really been doing in terms of calculus is writing the word limit. Okay, so now this is all that survived. So all I'm now going to do is plug in 0 for delta x. It's 4x plus 2 times 0 minus 3. 4x minus 3. Next problem. Okay? I made sure that that was the right answer. Okay? It's all algebra. There's no heavy-duty calculus. And this is the section where people get destroyed in calculus. Alright. Suppose I tell you that f of x is the square root of x minus 3. So, f prime of x is equal to... So, what we're doing is, like on an exam or on homework, they will say, use the definition of derivative to compute derivative of f of x equal the square root of x minus 3. So use the definition to find the derivative. Well, it's f of x plus delta x minus f of x over delta x. And this is a formula that you've seen in pre-calc. Now, what does f do to what's in the brackets? Well, it takes away 3, and then it takes the square root of it. It takes away 3, there's x. We take away 3, and we take the square root of the whole thing. If you can say it in words, then this becomes easy. I take away 3 from what's in the brackets, and then I take the square root of it, minus. I take away 3 from what's in the brackets, and I take the square root of it, all over delta x. Your main goal is to cancel out delta x over delta x. So, right now, I can't do that. So, I need to do something to this. I'm going to multiply it by something. Now, if I multiply it by 7 over x, since there's no reason for that to be 1, then I change the problem. This times this is no longer this. Okay? Don't change the problem. You can change the way it looks, but you can't change the problem. You can multiply only by 1. And the representative of 1 is going to be the conjugate. It's going to be plus the square root of x minus 3. And the bottom has to be the same as the top. Otherwise, the whole fraction will not be 1. This is 1. What's in these brackets times what's in the next brackets equals to what's in the original brackets. I just multiplied by 1. Now, remember 2 things. If you have a minus b and you multiply it by a plus b, you get a squared minus b squared. And if you have the square root of c and then you square it, you just get back c. So, including the square root sign, this is my a and that's my b. And I have the same a and the same b. On the right I have a plus b. On the left I have a minus b. This is equal to the limit as delta x goes to 0. And whenever you have a minus b times a plus b, you get a squared minus b squared. Well, a squared, well, a is under a square root sign. So when I square it, I just get back what's underneath the square root sign. X plus delta x minus 3. Minus b squared, which is just x minus 3. And the bottom is whatever it is. It's this times that. So make sure you put brackets. X plus delta x minus 3 plus the square root of x minus 3. All algebra. Didn't do any calculus other than writing down this silly limit stuff. Now, it comes together. X, take away x by negative 3, take away negative 3, that's gone. All that survived in the numerator is delta x. And in the bottom we have delta x times this big mess. Okay. Now, since delta x is not 0, this is 1. Now, I crossed out delta x. I just directly substitute. This is 1. If delta x is 0, that first square root sign is x minus 3 plus x minus 3. If you add, I don't care how strange these things look to you, they're the same. If you add something to itself 2 times, you get 2 times them. There's your answer. Using the definition of the derivative. Okay, let us try some more. Suppose you are told this time that g of x is equal to 4 over x minus 3. So then g prime of x is going to equal to the limit as delta x goes to 0 of g of x plus delta x minus g of x all over delta x. And this is going to equal to, now what does g do? Well, in the denominator, whatever in the brackets, it takes away 3. Okay, that's in the brackets. So in the denominator, I take away 3, and I put a 4 on the top. Minus whatever in the brackets, in the bottom, I take away 3 from it, and I put 4 on top. All over delta x. We didn't cancel out delta x over delta x yet, so more algebra and more writing this silly word or phrase limit as delta x goes to 0. So what I would do here is get a common denominator. I'd multiply the top by that times x minus 3. If you like, you can say over 1. And the bottom by the same thing. X plus delta x minus 3 times x minus 3. Okay, equals. Now, when I go to multiply this by that, that's going to cancel out, but it's there for the next subtraction. So I have 4 times x minus 3 left. Minus, when I multiply this by this, that cancels out. So I'm left with 4 times x plus delta x minus 3. All over this times that. Delta x times x plus delta x minus 3 times x minus 3. This becomes the limit as delta x goes to 0, 4x minus 12, 4x minus 12, minus 4x, minus 4, sorry, I factored out the minus, so it's plus 4 delta x minus 12. All over delta x times x plus delta x minus 3 times x minus 3. This is 4x, that's 4x, and we are to subtract them. They're gone. This is negative 12, that's negative 12. When I subtract it, I get 0. So the limit as delta x goes to 0 of minus 4 delta x all over delta x times x plus delta x minus 3 times x minus 3. The good thing is, since x is not going, delta x is not going to be 0, those delta x's cancel out. So now I plug in 0 right there. So I get negative 4 over x plus 0, which is x minus 3, times another x minus 3. The derivative is 4 over x minus 3 squared. Let us try another one. Let us use the alternate definition. Suppose you are told f of x is equal to x squared. Find f prime of 3 using the alternate derivative formula. Okay, so using the alternate derivative formula, remember f prime of c is equal to the limit as x goes to c, the limit as x approaches c of f of x minus f for c all over x minus c. Now c is 3. So f prime is 3. So whether you write this down or not, that's your call. This is equal to the limit as x goes to c, which is 3, of f of x minus f of 3 all over x minus 3. Well, f of x was x squared. So this is the limit as x goes to 3 of x squared minus, well, f of anything. What does f do to what's in the bracket? It squares it. So I'm going to square 3 all over x minus 3. If I direct substitute, I get 0 over 0, which means I'm in some trouble. I have to cancel out that 0 over 0. And since it's a derivative, you should have known that from the get-go. This is the limit as x goes to 3. Well, if 3 makes that polynomial 0 in the numerator, then x minus 3 must be one of the factors. And the other factor is x plus 3. It's the difference of squares. And we divide this by x minus 3. If you cross that out as 1, and that's all you say or think, you're mistaken. You can cross it out as 1 because x will never be 3. This will never be 0 over 0. It won't happen. So yeah, that's 1. So then you have the limit as x goes to 3 of x plus 3. I'd substitute. 3 plus 3 is 6. I plugged in 3 for x. And this makes sense because remember, if f of x was x squared, we proved already that f prime of x is 2x. But that implies if I plug in 3 for x, f prime is 3 will be 2 times 3 or 6. So yeah, we have the right answer. Okay, and here's all our work. And the only calculus we did was writing down limit, writing down limit, writing down limit, writing down limit, and then plugging in 3 for x. And plugging in this number in here, that's just a valuation. That's not even calculus. But it's the calculus that told you to plug it in. Okay, let us try another one. Suppose I told you that g of x is 2x squared, and I say find g prime of some numbers 3, 4, and 5 using the alternate derivative formula. Now notice something. When you plugged in 3 into the alternate derivative formula, you got back a number. So if you do the same thing for g prime of 3, you'd get back, I'm pretty sure, 12. But then you're going to have to use the formula all over again to get back 8. Well, that makes no sense. Oh, 16. And then I guess you'll get back 20. So you don't want to use this long formula 3 different times. So how about we not find, we'll use the alternate formula because they said we have to, but how about we just find g prime of c. Let's suppose g prime of c was, I don't know, 5x. I'm sorry, 5c. So then g prime of 3 would be 5 times 3, or 15. And then g prime of 4 will be 5 times 4, or 20. Okay, so let's find out what g prime of c is using the alternate formula. G prime of c, by definition, is the limit as x goes to c of g of x minus g of c all over x minus c. This is equal to the limit as x goes to c. Well, g of anything, you square the anything and double it. So I square it and I double it. Minus g of c, I square it and I double it. All over x minus c. This is equal to the limit as x goes to c of, in the numerator, I can factor out a 2. X goes to c. In the numerator, I have the difference of squares. X and c are being squared. One time I add them, the other time I subtract them. Over x minus c. Something's definitely bothering me here. Okay, so now since x will never be c, that won't be 0, because the only way this is 0 is if x is c. C minus c is 0, but x won't be c. So this is 1. So we have the limit as x goes to c of 2 times x plus c times the 1. I won't bother timesing it by the 1. Now, just plug in c for x. You get, so I'm not writing down limit because I'm plugging in c for x. I get 2 times x plus x, which is 2 times 2c, which is 4c. So, g prime or c, this equals all this mess. It equals to this, which 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 equals to 4c. G prime of c is 4c. Okay, so now I can answer my questions. What do you do to what's in here? You multiply it by 4. So g prime of 3 will be 4 times 3, or 12. G prime of 4 will be 4 times what's in the brackets, or 16. And g prime of 5 will be 4 times what's in the bracket, or 20. You definitely don't want, now you could have plugged in c everywhere I put a 3. You could have plugged in 3. You could have plugged in 3. And at the end, you would have had 12. And then you know what? You would have had to do this all over again with g prime of 4. You don't want to do that. You don't want to do it. If you're only asked to find it one, g prime of just one number, fine. You can plug in the value for c at the beginning. But if you're asked to use the alternate formula to find g prime of a number of values, don't find g prime of, say, 3. Find g prime with c. Because then it becomes easy. G prime or c is 4c. There it is. So now, this is just the function. Don't worry about, oh my, it has this prime here. Nonsense. It says the name of the function is g prime. It could have been g, it can be H. You know what? It can be G triple prime. It doesn't matter. It's a name. It says that what does G prime do to C? Oh, it multiplies it by 4. So I multiply that by 4, I got my answer. I multiply that by 4, I got my answer. That by 4, I got my answer. Know what the definition is for the function in words. Now, I want to talk about one last thing. We'll actually prove this. A fact, a theorem. If f of x is differentiable at x equals c, then f of x is continuous at x equals c. Now, just for the record, say you have a function that goes like that. There's a corner point right here. Now, the derivative is a limit. F prime of x is a limit. Delta x goes to 0 of f of x plus delta x minus f of x over delta x. For this limit to exist, it better be true that the limit from the left is equal to the limit from the right. But these limits are they're slopes, so we don't really have to do too much to see what's going on. With respect to so we're concerned about that point right there at C. It turns out that the left derivative is that. But you know what? The right derivative is just the slope of the line. They don't match. And even if we had a curve here, from the left, at this point, from the left, the slope is going that way. From the right of that special point, the slope is going that way of the tangent line. So why did I do this? F of x is not differentiable at every point. F of x is not differentiable everywhere. Of course, it's a limit, and some limits do not exist. Okay, so let us prove this, and then we'll be done. So now, I claim that, just give me a moment. I claim that if x goes to c of f of x equals f for c, then this is continuous. This is a shortened version of what we did before. Now look, the fact that this limit exists, it implies that the limit as x goes to c minus of f of x exists. It implies that the limit as x goes to c plus of f of x exists, because only when you have those two can you say that the limit of this exists. That was 2, and you need that whatever this limit is, it needs to equal f for c. Okay, so really, or let's call this L. You need this to be L, but L is this. You need for this to equal C. But built into this equaling f for c, that means this exists. That means 1a and 1b must be true. Okay, so this is just a shortened way of verifying that a limit exists. By definition, this means f of x is continuous at x equals c. Okay, so you don't need that for the proof, but let's just state it. So now look, f of x is equal to f of x plus, okay, minus f of x equals f of x minus f of c plus f for c. All I did was take away something and add it back, and I can bracket it like this if I like. And this is equal to f of x minus f for c divided by x minus c, as long as I multiply by x minus c. That's the first bracket, plus f for c. Okay? Now, let's take the limit of both sides, the limit of this side and the limit of that side as x goes to c. The limit as x goes to c of the left side, it equals to the limit as x goes to c of this mess, which is f of x minus f for c over x minus c times x minus c plus f for c, the limit of that. But we have some limit rules. It's saying that I can distribute the limit over addition. This is the limit as x goes to c of f of x minus f for c over x minus c times x minus c plus the limit as x goes to c of a constant. F for c is like 11. It's a constant. Okay, now here we have a product. This is equal to the limit as x goes to c of f of x minus f for c over x minus c times the limit as x goes to c of x minus c plus this limit, which is just f for c. Now, this limit here, well, we'll come back to that limit. This limit here is 0, because c minus c is 0, plus f for c. Now, it does matter what goes here. Okay, you can't say, oh, this times 0 is 0, plus f for c is f for c. It is not true that when it comes to limits that anything times 0 is 0. Undefined times 0 is not 0. But we don't have a problem here. This limit is very well defined. It is defined as f prime of x. Now we can say f prime of x times 0 is 0. This really is 0. Plus f for c is equal to f for c. That is, this limit is equal to f for c. But that means that f is continuous at c. Okay. Hence, f of x is continuous at x equals c. Okay, if you're differentiable somewhere, you have to be continuous at that point. Okay, that's a necessary condition for a derivative to exist. May not always be sufficient, may not always be enough, but if you're not continuous at a point, this graph right here, no way is it differentiable at 5 because it's not continuous at 5. If it was continuous at 5, is that enough for me to say it's differentiable? No, because it may go like this. The left-hand derivative is that. The right-hand derivative is that. Those two slopes are not equal. Hence, the limit, which is the derivative, doesn't exist. But no way could it be differentiable if the point is missing. There's a nice smooth curve. If I remove that point, it's not differentiable at 5. Not because I'm telling you, but because we proved it. If it's differentiable at C, it must be continuous at C. That's what this theorem proves. Okay, this completes the video on about finding the derivative of some functions using their derivative and alternate derivative formula.